Hi guys, in this video I will show you how you can create this kind of spiderweb effect with Blender geometry nodes. So yeah, let's start. First we delete the things we don't need, and then we set up a new geometry nodes, delete the input. And first, let's create some objects in our scene on which we can instance the spiderweb. So I choose the Suzanne, maybe rotate it a little bit, and also create another, maybe scale this up a little bit so it looks more random. And then we put all of these in a new collection. So create a new collection, I call this test, and yeah, so we can disable the collection for now. And back in our geometry node setup, I pull up the collection with the collection info node, and here I choose test. Here you can see that we have this, and so yeah, the idea to create these lines is to first distribute some points and use these points to place some lines between them. So first I use the distribute points on faces node, and to create lines I simply take any mesh line object, doesn't really matter. We can take the mesh circle, for example, and then we split up these lines. So take the split edges node, and now we have these lines which are all separated from each other. And the idea is to place these lines randomly and choose a point we have distributed here as the position for the points of the lines. So we use a set position node. Sorry if you can hear my dog, by the way. I have to do this tutorial kind of spontaneously and one take, because my girl and my dog want me to come with them to the Baltic Sea for a few days. So yeah, that's kind of like a last minute tutorial I do here. So yeah, sorry for that. Okay, so we have these lines here, and now we simply want to choose the position of a point randomly based on the index, and we can do this with the transfer attribute node. So transfer attribute, and use our points as the source, and here we can choose index, and I have to choose this here to vector because the position is a vector. So take the position, and right now if I put this in here, and I have to choose the index here, so I do this randomly with the random value node. And when I increase this, it doesn't work because I forgot to realize our collection. So realize instances here, and this should work. And to displace our collection and our lines, I can use the join geometry node, but I can simply also toggle this on here. And yeah, you see that our lines only get instanced here. That's because we have to set the maximum value to the amount of points I've distributed here. So I have to increase this a little bit. But a way to do this nicely is to simply take an attribute statistic node, and take our points, and we want the maximum amount of indices. So I take the index. And by the way, I use the Node Tabber add-on, which lets me search for nodes quickly by pressing Tab. So Tab, and then, for example, press CTM, which gives me curve to mesh. It's a really nice little add-on. And okay, so I put the index here as attribute and the maximum value to the maximum of our random value node. So now everything should work nicely. And here I can control the amount. So maybe I can take the group input and call this line count. Now I can control it with my modifier. Yeah, rearrange this a little bit. So the next step I'd like to do is to create a little bit of slack. So all these lines like get pulled down by gravity a little bit. And the way to do this is to convert them to a, how is it called? Mesh to curve. Yes, to a curve. And based on a factor, I want to pull this down. So when we take a set position node, and I want to access the z-axis, so combine x, y, and z. And we take the spline parameter, and here we can access the factor, put it in a z. And now you can see it's kind of linear from start to the beginning, from start to the end of the curve. And when we take, for example, a float curve, and maybe we choose a curve like this, and also we need to resample this curve to give it more geometry. So resample curve, and maybe a higher amount here, or we can even set this to length, which I prefer actually, because it evenly subdivides our curves. So shorter curves get less geometry, and yeah, that's the more logical way, I guess. And yeah, so when I multiply this with a negative value, you can see that slack appears, but right now the curve is really ugly, so we can try it to recreate it with this float curve node, but I don't like it this way. I actually prefer to do it mathematically. So let's do this quickly. First I take the map range node and remap the range from -1 to 1. And then I take the absolute, which turns our negative values into positive values, simply said. And to give it this nice curve interpolation, I use the math power node. And when I say we use 2 as the exponent, you can see this nice curve appearing. But we need to remap this again. We need to invert it, so to say. I do this by subtracting it from 1. And now you can see we're getting closer. And if we invert this by multiplying it with -1, you can see the nice result we're getting. And what I like to do is I create another multiply node, and here I can control the amount of slack. I do this with a group input again and call this slack amount. And right now I can control the slack really nicely. So I leave it at 1 for now. And what I don't like about the results so far, I mean, it looks really nice, but there's one issue, and that's that shorter curves, for example, when I pull them up close together, or you can see it here on this curve, the shorter curves get the same amount of Z displacement as the longer curves, and I think a more natural way to do is to base it on the length. So the longer the curve is, the more slack it gets. And yeah, so we can simply take the length of the spline and multiply it with the result. So now everything should work as expected. The longer the lines, the more slack we get. And yeah, that looks good so far. So let's quickly rearrange this a little bit and make it more beautiful. Call this slack and this baselines, and maybe I do this here and call this instancer geometry. So we can take, for example, other primitives like a cube, and it should work also. Yeah, so I don't see the cube for now. Can join geometry. No, join geometry. Yeah, you can see it. But let's work with our collection. So the next step is to basically do the same thing again, but instance these curves between our first level of curves. And I do this with another method, not the method I've used here based on the index. I do this with a proximity node, which is like a more simple way to do it. And we also can do this here in our first iteration, but I wanted to show you different methods. There's a third method actually, which includes raycasting, which is my preferred method. I guess it's a little bit more complicated, but it has the advantage that we can check, for example, for the normals of the ray direction, and with the raycast method, we, for example, can exclude these lines inside our meshes. But maybe that's for another video. And for this, I use, for the next step, I use the proximity method. Okay, so first we instance some lines onto our lines. So to show both, I use the join geometry node here and take the curve line object. And right now you can see these lines appearing, but I don't want this to look so uniformly, so I can do this multiple ways. One quick way to do this is maybe a random node again, random value, and set this to Boolean. So, and here we can do selection, and here we can control a probability. So let's also control this with the group input node and call this maybe level 2 I can't write right now. Probability. So now my idea is to place these endpoints based on a proximity to our first level. So let's do this by using the set position node. And we want to set the endpoint. So there's a node for endpoint selection, and we want to exclude the start. We want to set the end, and then we use the proximity node. And the target is our base here. And we need to set this to, let's say, points. Edges would work also. And then we can simply plug the position in here. And nothing happens because this needs to be a mesh, I guess. Yes, so we need to convert it to mesh first. And that doesn't work so far because we again have to realize our instances here. And now you see something is happening. And yeah, see these lines appearing. And to make it more random, right now every curve gets instanced in the same direction. So we can, for example, rotate them randomly. And I take a random value node. That was my doc again. Sorry for that. And I use 2pi, which is tau. You can also put tau in here for the random rotation. And yeah, now everything gets rotated randomly. And now the result should look a little bit more random. Yes, it looks good so far. And you might not see it, but there's actually a little problem. For example, I don't want these lines connect to itself. So when I put slack in here, so let's maybe quickly do this again. To do this, I can copy this. Let's hope that I can copy it. I haven't tested it. That's the downside of doing all one take. And nothing happens because I have to resample it again. Yeah, does work. And yeah, that's actually my preference. You can do it this way, but I don't like it. Like you can see here, these little things appearing. And yeah, to solve this problem, we can, for example, rotate these instances not randomly in all directions. We only rotate them randomly around our curve. So to take the rotation of the curve into account, we can take the curve to points node, for example, and use the rotation here. And right now everything gets rotated in the same direction as our curve. So we can, for example, take a rotate Euler node, and we want this to happen on the local axis. And if we put 90 degrees in here, you can see that it gets rotated along its, I don't know what direction this is called, the tangent maybe. So yeah, here you can see it. And we want to rotate it randomly around the x-axis. So to do this, I take a combine x, y, and z, put it in here. And here we have to put 90 degrees, which in radians is half pi. So pi divided by 2. And here I can again put a random value in here. So I take the existing one, put it to float, and to describe a whole rotation I can type tau in here. And now every line gets rotated randomly around its axis, which is the tangent of our base curve. So yeah, if we reconnect everything again, so we don't need this here, it should look a little bit nicer. So yeah. And another important thing is the length of our curve here, which describes the kind of like the search radius for our proximity node. So when I increase this value, you can see that the second iteration of lines gets kind of more length. Sorry for my bad English. So I can make this accessible with our group input node again. And another group input. We call this level 2 length. Yeah, that works really nice. And Slack also works. And the level 2 length part we did here, we can also do it randomly here. So for example, if we put a random value again in here, we can make this more random, but yes, for this tutorial, maybe let's keep it a little bit simpler. And yeah, so that's our second iteration. I have a duplicate here, so I can keep it more compact this way. And let's put this in a frame and call this level 2. And maybe we can make a seed also accessible in our modifier. So let's take group input again and create the seed socket. I like to put it at the top. And now we can put this everywhere where we can have a seed. So let's do this again here. Oh, can like this. And another thing I've just seen, I mean, we can call it a mistake, but it isn't really a mistake. It's the curve to points node here, which is set to count, but I want to set it to evaluate it. So we take the geometry we have created here into account, not a new geometry. So we can also set it to length, but maybe evaluate it is good. And yeah. So to make a new iteration, we should simply can take this iteration and connect it again. So let's hope for the best. Take another join geometry node. And yeah, it's working. That's good. But we want to maybe have separate inputs. So here we maybe decrease it a little bit. So have a lesser probability for level 3. Call this level 3 probability. And the length should also be a little bit lesser, so call this level 3 length. And let's have a quick look. So yeah, this should be it. And now we have this new level appear. And slack is a little bit harsh at the moment. So decrease it a little bit. The cool thing is I can dynamically change the objects in our collection. And I'd like to create another iteration. So again, we copy this whole setup here. And right again, we create new inputs for the probability and the length. So level 4 probability and level 4 length. And maybe to keep it concise, we can call this first level also level. And remember, we did this on another method than the other levels. And here we only have the count input, no probability and no length. But you also can do it this way. And yeah, so let's quickly adjust everything. So that it looks nice. Yeah, I think this looks good. And maybe for the final step, let's turn our curves into a mesh. So curve to mesh node. And for the profile, I use the circle. Lessen the geometry, maybe to 8, because it has to be really thin. 1. And yeah, you can see now that we have this kind of like spider web. I hope you do not hear my dog licking itself. I'm really sorry, but yeah, it is what it is. And yeah, that's the setup. I hope you can follow this tutorial. And again, sorry for my really bad English, but yeah, it is what it is. You have to deal with this. And see you next time.